All right, let's take a look at this question from last year's 250 midterm. So we start with our supply and demand model, which would give us our usual supply and demand graph, and we're going to be looking for an equilibrium price and quantity, and then we're going to be looking for the impact of a $10 subsidy. So for this model, if our subsidy is 0, then we're going to get to our equilibrium price and quantity, which should work out to 40 units at $250. But let's build up to that, and let's start by explicitly building in the subsidy. Now, a way to think about the subsidy, the way I'm going to treat it here is there's the price, and then the seller gets some additional amount of money from the government. So we got the price determines how much do people buy, but the price plus the subsidy determines how much sellers are willing to give up. So notice we've got some price. Let's just call it $245 for now, right? Something a little lower than $250. At $245, buyers are going to want more than 40 units, right? So far, so good. Nothing crazy there. But at $245, sellers don't want to sell very many units. So if we just push the price down and we don't account for that in our supply curve, what we would have is at this price, we end up with a low quantity. But it's not the price that's going to determine how much they want to sell, it's the price plus the subsidy. So their quantity is based on this price of $245 plus 10 makes $255, puts them at this point on the supply curve. It moves them up and to the right compared to our equilibrium without a subsidy. So let's find out, is this actually $245? It's not going to be exactly $245 because there's no guarantee that we split that $10 equally between the buyer and the seller. It's going to determine on the relative elasticities, the slopes of these lines. So if the lines look more like this, we're going to have more of an impact on pushing down the price to buyers. Sellers are going to get a relatively modest part of that subsidy in a case where demand is very elastic. Right? In that case, maybe the price goes down to $242 and the buyers end up with $252 after the subsidy. If we go like this, a relatively elastic demand curve and a relatively inelastic supply curve, in that case, we're going to be moving further up the supply curve, and the sellers are going to be getting a bigger reward out of this subsidy in a case like that. Now, in this case, it looks like minus 5Q, looks like our slope is going to be steeper than our supply curve, so we should expect probably lower than 245. But let's verify. So like I said, what determines the quantity that we get, what matters for the seller, is not the price, but the subsidy and the price. So we just throw that subsidy over there, and like we were doing in class, I'm going to leave it as S rather than as 10. I know I'm adding in an extra symbol here, but honestly for me, it is just a little bit easier this way. So as you're following along, if you start to get bothered by the S, just pop in a 10. All right, so let's get to it. Now we're going to probably just set these equal to each other the way we might have if we just said price equals price. So we need to move this S over. So we can subtract S from both sides. And now we have price equals 2Q plus 170 minus S, and price equals minus 5Q plus 450. These are both equal to the price that the buyer pays out of pocket, not the price that determines whether or not the seller is covering their costs. We could flip this around. We could think of this as P and then this as P minus S, and then we would just change where we put this S in. That's a good thing to try and practice. That might be a good exam question for me to put on the midterm, telling you to explicitly model this as P being the higher price and P minus S being the subsidized price. But let's go ahead and look at it this way. So 2Q plus 170 minus S equals minus 5Q plus 450. we can add 5Q. We can subtract 170. And we can add S. That gets rid of this and this. We're left with 7Q equals, the 5 is gone. We've got 450 minus 170. 170 is the same as minus 150 minus 20. 450 minus 150, that's something I can do in my head. That's just 300. So I've got 300 minus 20. 300 minus 20, I can do that in my head. That is 280 plus S, right? So 450 minus 150 is 300, minus 20 gives us that 280. Now we've taken care of that 170 plus the S. Cool, we've got everything. We haven't lost anything yet. Now we divide both sides by, already made a mistake, not by Q. Let's divide by 7. I don't need to find out what 7 is. I know what 7 is. I care about what Q is. So 7/7 of Q is 1Q, which equals 280 over 7 plus S over 7. 280 over 7, that is divisible by 7. 28 is 4 times 7, so this is 40 plus S over 7. Good. So we got that 40 back. Let's go ahead and plug this into one of, well, let's see, we should plug it into our demand curve. So we've got Q equals 40 plus S over 7. And it's worth remembering, it's worth noticing that with a subsidy, we expect to buy more. So if we give buyers an extra 10 bucks for buying something like a solar panel or whatever, that we get a higher value for quantity means that at the very least we haven't made some obvious mistake, right? If we had a negative sign there, we would want to go back and figure out what went wrong. And in this case, the natural place to look would be with this S, right? So had I gotten, let's say I had added S onto both sides, and then I got minus S over 7, I just go back and say, oh, I shouldn't have added that, I should have subtracted. But in any case, pretty sure this is correct. So there's Q. Price, we've got, let's look at the demand curve, minus 5Q plus 450. So now we can make price a function of the subsidy. So price equals minus 5 times 40 plus, not 5, sorry, S over 7. Sorry, my S sometimes looks like a 5. S over 7 plus 450. Let's go ahead and simplify. This is going to be minus 200. This will be minus 5S over 7, and then plus 400 plus 50. Forgot that. Minus 200 plus 400, that gives us plus 250. So we've got 250 minus 5S over 7. Cool. So now this is quantity as a function of, sorry, not quantity, price. This is price as a function of the subsidy. So with a subsidy of 0, we get 250. And as we increase our subsidy, we're going to be lowering the price because we're pushing down the demand curve. The price that the sellers get is going to be $10 higher than this. So price to seller is going to be 250 minus 5S over 7 plus S. Right? We're just going to bump straight up from here by S. All right, now I am looking at a student email asking if this student got things correct. So let's go ahead and plug in S equals 10. So what we'll get there is 250 minus 5 times 10 over 7, which gives us 250 minus 50 over 7. And to get rid of this 7, I'm going to multiply this by 1. right? 7 over 7. So let's see, 8 times 250 would be 2,000. So this is going to be 2,000 minus 250, which is going to be 1750 over 7 minus 50 over 7. Pretty sure I got that right. And then this turns into 1700 over 7. And that is not evenly divisible, so let's be lazy. 1700 divided by 7, 242.85, which is remarkably close to what this student got in her email. 242 and 6/7. That's a nice round fraction there. So 242 and 6/7. And then for the seller, we would just add in an extra $10. So plus 10 for the supply curve. Cool. Let's close that here.